Okay, hi everyone. This is going to be our last video on empirical and molecular formulas. We're taking that final step. So just a quick refresher to get us started. Don't forget that the empirical formula is the lowest whole number ratio of elements in a compound versus the molecular formula, which is more or less the true chemical formula, giving us the actual number of atoms in that compound, not just the lowest whole number ratio. So when we are finding the molecular formula, the first thing we need to do is we need to find the molar mass of the empirical formula. We then divide the molar mass of the molecular formula by the molar mass of the empirical formula. And then we get some number. If that number is 1, then the molecular and the empirical formulas are the same. If they are not, then we're going to multiply the empirical formula by the number we found in step 2, and that will give us the molecular formula. So today we're going to take that final step and we're going to figure out how to calculate the empirical formula. So the first thing we need to do is determine the moles of each element in our compound using molar mass. Okay, we've done this before, not too hard. The next thing we want to do is divide the number of moles of each element by the element with the smallest number of moles. Okay, and then we're going to round our quotient to the nearest whole number. And then we're going to write the empirical formula using the mole ratio that we found in step 2. Those numbers are now going to become the subscripts. Okay, so let's go ahead and work through an example. A compound was analyzed and found to contain 76.3 grams of copper and 9.6 grams of oxygen. We're being asked to find the empirical formula of the compound. Well, the first thing we need to do is find the moles of each. So we want to find how many moles of copper that is and how many moles of oxygen. So we're going to use the molar mass that we find on the periodic table and go ahead and divide. So we find out with copper having a molar mass of 63.55 grams per mole that we have 1.2 moles of copper. And then with oxygen, we go ahead and we find out we have 0.6 moles of oxygen. Now we want to compare these two numbers and find the smaller one. Well, in this case, quite clearly, the oxygen is smaller. 0.6 is less than 1.2. So we're going to go ahead and divide both of those values by the smaller number. So we're going to end up with 2 for copper and 1 for oxygen. Now, one thing I want to point out, you should never have a value less than 1 when you're going ahead and doing this step in the empirical formula. If you did something wrong. So in this case, our empirical formula is Cu2O. Okay, so one hint, sometimes instead of being given masses, you're given percentages. If that is the case, you're going to assume that your sample weighs exactly 100 grams. And then we can just convert those percentages into masses. So what is the empirical formula of a substance that is 94.1% oxygen and 5.9% of hydrogen by mass? So I'm going to go ahead and convert those percentages into mass. So I'm going to 94.1 grams of oxygen and 5.9 grams of hydrogen. So if we use their molar masses, we're going to calculate how many moles we have of each. So I end up finding that I have 5.8 moles of oxygen and then 5.85 moles of hydrogen. So the value for hydrogen is slightly smaller, so we're going to go ahead and divide by that one in this case. If we go ahead and do the math, dividing both by the smaller number, we find out we have 1.005, which is really, really close to 1. So we're just going to round it to the nearest whole number. And then for the hydrogen, it's exactly 1. So my empirical formula is just simply OH for hydroxide. Okay, next hint. If a mole ratio ends in about 0.5, we're going to multiply all of the numbers by 2 to get whole numbers. If a mole ratio ends in 0.33 or 0.67, we're going to multiply all the numbers by 3. Okay, so basically the idea here is we don't want to have fractions. We want to have whole numbers as much as possible. So this will help get us to that whole number. Okay, so NutraSweet, the artificial sweetener, has a mass of 57.14% carbon, 6.16% hydrogen, 9.52% nitrogen, and 27.18% oxygen. We're being asked to calculate the empirical formula of NutraSweet and find the molecular formula. And we're given the molar mass of NutraSweet is 294.30 grams per mole. So in this case, we're given percentages. So again, we want to convert these to grams. So 57 grams of carbon, 6 grams of hydrogen, 9.5 grams of nitrogen, and 27 grams of oxygen. And we want to find the moles of each. So we're going to divide by the molar mass. So I end up with 4.76 moles of carbon, 6.11 moles of hydrogen, 0.680 moles of nitrogen, and then 1.70 moles of oxygen. And again, I want to find the smallest number. So in this case, the smallest number is going to be my nitrogen, the 0.68. So I'm going to take each of those number of moles and divide by 0.68 moles. So if I go ahead and do that, I end up with 7 for my carbon. Okay, so really nice number there. 1 for my nitrogen. Hydrogen is 8.98, which is really, really close to 9, so I'm okay rounding that one. And then for my oxygen, I end up with 2.5. So I can't really round that to the nearest whole number because it's smack dab in the middle. So what I'm going to do is I'm going to multiply all of those numbers by 2. So 7 is going to become 14, 1 is going to become 2, the 8.98 that's rounded to 9, that's going to become 18, and the 2.5 is going to get rounded to 5. Okay, so that gives me a formula of C14H18N2O5. Okay, so that's my empirical formula, which is half the problem. Now I want to find the molecular formula. So I know the molar mass of my compound overall. Now I need to find the molar mass of my empirical formula. So I go ahead and calculate that all out. So 14 times the mass of carbon, 18 times the mass of hydrogen, 2 times the mass of nitrogen, and 5 times the mass of oxygen. Remember, your numbers might differ slightly depending upon what periodic table you use, but you should end up with a value pretty close to 294.3 grams per mole. So if we think about this, that's pretty much exactly what the molar mass of our whole compound is. So in this case, our molecular and our empirical formulas are the same. Okay, so we've already found the molecular formula. If it wasn't, and we got some other value, then we would go ahead and multiply our empirical formula by that value. So I hope this helps. If you have any questions, please go ahead and let me know. Have a good day. Bye.